Okay, sorry for the delay. Just before we start, can I please get confirmation that you guys can hear me? I'm going to share my screen in a second, but just confirm that you can see me and that you can hear me clearly. Okay, perfect. Okay, can you guys see my screen? Okay, cool. So, Assalamu alaikum and good morning. Welcome back, guys, to Grade 10 Maths by Inspired Teens, where in today's lesson, we are going to be just finishing a restriction on fractions, which is part of like simplification and factorization. And then we'll be moving on to exponents, equations, and inequalities. Okay, so I hope you guys have been practicing factorization, right? So again, if you forget something, you can rewind, watch the video again. You can go look at the examples again and just constantly practice, right? Make use of past paper websites and past papers to practice factorization. Okay, it's important. Let's talk about restriction on fractions. Okay, so just before this, we discussed simplification of fractions with addition and subtraction. Okay, so we did some complicated examples with factors as denominators. Okay, when you have unknowns. Okay, there is one more note. I'm going to add it to this. It's just something I want you guys to know. Okay, so let's talk about this restriction on fractions, right? So it says all fractions with variables in the denominators will have restrictions, as the denominator may not equal to 0. If the denominator becomes 0, the fraction is undefined. All of this is true, and we should follow these things that they have just said. Okay, so example, determine the value of x for which the fractions will be undefined. So whenever you see the term undefined, you always need to think of divided by 0. Anything, whatever's in the top, okay, let's put a question mark. Whatever's in the top, if you're going to divide anything, by 0, you are going to get undefined. If you type in your calculator, if you say 50 divided by 0, you are going to get a math error. Okay, so for now in school, when you divide by 0, from now up until matric, it is undefined. Okay, so in this case, they say for which x values, okay, will the fractions be undefined? So basically we know, oh, okay, the denominator needs to be 0. So we take our denominator, which in this case is just x minus 1. We say x minus 1, and we equate it to 0. This is going to help tell us the values that make it undefined, because undefined is when it's 0. So that's why I equate it to 0, because I'm trying to find out when it's 0, what is that x value. Then I just leave the variable alone. So I take 1 over to the other side as a positive, or I just add 1 on both sides. X is equal to positive 1. So basically when x is equal to positive 1, fraction is undefined. Okay, let's do the next one. Let's do this one. I will. Okay, number 2. Again, we are doing determine which value for x the fractions will be undefined. So you're going to take your denominator and you're going to equate it to 0. So this is going to help to tell you which value for x this is going to be undefined. So by the way, when I substitute x here as 1, it's going to become 1 minus 1, which gives me 0. Okay. So in this case, I take 1 over to the other side, it becomes negative 1. Then I divide both sides by 2. I'm guessing you guys are fine with algebra. When I divide both sides by 2, I actually get negative 1 over 2. So negative 1 over 2, or negative a half, is what will make the denominator 0. And that denominator being 0 will make the fraction undefined. Let's look at this, how we meant to like factorize. Or do they just want it in terms of b? So basically, I take the denominator, I equate it to 0. I take 2b over to the other side, it becomes positive 2b. Then I divide both sides by 3. I get x is equal to 2b over 3, or 2 over 3b. I'm guessing that they just wanted the answer in terms of b there. Okay, that's simple enough, and I hope that makes sense. Determine the restrictions for the following fractions. Okay, so when we talk about restrictions, right, one of our main restrictions is that the denominator cannot equal to 0. The denominator cannot equal to 0. As soon as the denominator is equal to 0, that is an issue. Okay, so what we do is anything that makes the denominator 0, okay, we need to find that value and say, okay, this is a restriction. X cannot be equal to this. So another way of solving it is my denominator is x squared minus 1. I can say x squared minus 1 cannot equal to 0, equal to a little line, and I can solve it like a regular equation. So I take 1 over to the other side. So x squared cannot be equal to 1. And then I can square root both sides. Okay, remember, yeah, I'm going to get plus minus. So that cancels with that. X cannot equal to plus or minus 1. Okay, plus and minus is outside of the set. Why plus or minus? Whenever you take square root of both sides, it's plus minus. This is still part of algebraic expressions. It's the first topic that we did. Next, we'll be doing exponents, equations, and inequalities. And then after that, we'll be going into trigonometry. Okay, so x cannot be equal to plus or minus 1. I have determined the restriction. So let's see another way of doing this. They want us to determine the restrictions. So basically, I take anything in any denominator. In this denominator, in that denominator, anything in any of the denominators that's going to make this 0, I need to restrict it. So in this case, if this part of the denominator is 0, it's going to make it undefined. So I need to restrict it. I say x minus 1 cannot equal to 0. Therefore, x cannot equal to 1 when I take 1 over to the other side. Okay. What about this? This is multiplication. This is like a times b. Okay. So if it was a and b, if a is 0, the entire thing is 0. If b is 0, the entire thing is 0. So neither of these, neither of these, what you call them? Neither of these factors of this multiplication can be equal to 0. Okay, so what I have to do in that case is I have to say that x new. I have to say that x plus 2 cannot be equal to 0 because that makes the denominator 0, nor can x minus 1 equal to 0. Okay, so this is a repeat of the other one, so we don't actually have to do it again, but I'll just do it again because it's a repeat of this one. Okay, but it's fine. So here, when I take 2 over to the other side, x cannot equal to -2. And here, x again cannot equal to 1. We know that already. So basically, these are the two restrictions. Okay, restriction is what x cannot be equal to. So there's another way of solving it by just using a not equal to sign instead of the equal to sign. In this case, you see the question was phrased differently. They say which x values will make it undefined. So I said when x is equal to 1, it will be undefined. When x is equal to -1/2, it will be undefined. When x is equal to 2 over 3b, it will be undefined. In this case, they ask what are the restrictions, then it's phrased differently, so the answers are slightly differently structured. In this case, x cannot be equal to plus or minus 1. Why plus or minus 1? Because remember, you always use brackets, guys. If you're not using brackets, you are going to fail miserably. Okay, so whenever you square x, okay, not going to fail miserably, but it's important. Whenever you substitute any value for a variable, you always use brackets. So if you try putting -1 or 1 squared in your calculator, both are going to give you +1. Okay, if you're going to put this in your calculator, you are going to get -1, but this is incorrect notation. You cannot express it like this because you need to put brackets. What this is basically saying is -1 times 1 squared. That's what this is saying, which is not what this is. Okay, so please be careful. Okay, these two, always use brackets. Right, now let's move on. Okay, so we're done with this. Let's move on to exponents, equations, and inequalities, where we're going to first discuss the rules of our exponents, which I think you've been doing since grade 8. All right, so let's go through them. Maybe some are new, but most of this has been done from grade 8. So let's go through them again and understand them. So the first of which is a to the power of x times a to the power of b is equal to a to the power of x plus b. So basically, when you have the same bases, a, and different exponents, okay, it doesn't matter if they're different or the same, but same bases multiplied by each other. That's important. It's a multiplication. Then you can add their different powers respectively. So in this case, it's a to the power of x times a to the power of b. This becomes a to the power of x times a to the power of x plus b. Just give me 1 second. Okay, what is also important is the reverse of this. What do I mean by the reverse? Okay, is going backwards. So when you are given b to the power of x plus y, okay, you need to remember that b to the power of x plus y, working backwards from this formula, you can separate each power to the base. You can write this as b to the power of x times b to the power of y. That is equally as important. Knowing the reverse of it is equally as important as knowing the forward way. Okay, technically none of them are forward or back, but knowing both ways is important. Are they going to be in class during exams? Yes, they should be. Should be class going on during exams. Okay, then we have this one, okay, which is instead of multiplication of same bases, we have division of same bases. So we have a to the power of x divided by a to the power of b. So same bases in division, then I can subtract my exponents. Same bases in division, I can subtract my exponents. Okay, so in this case, I also need to know backwards. So what's important is if I have b to the power of x minus y. Okay, so now I'm going to work backwards. Okay, b to the power of x minus y. Firstly, what's important is you need to know that you can actually write this as b to the power of x times, I know we worked with division, but we're going to say b to the power of x times b to the power of negative y. Okay, so it's like technically you're doing addition, but it's like you have x plus negative y, which is the same as that. Okay, and then remember when you do addition, you just multiply them. Oops. You just multiply them like that. Okay, so that's important as well. You'll see it's very common that you just do that instead. But it's also important to note that this is also equal to b to the power of x over b to the power of y. Okay, exponential rules. Number 3. This one is referred to as power to a power. It is basically when you have a base to the exponent, so base with a power, and that whole thing, you raise it to another power. Okay, power to a power. How do we simplify this guy? This guy we simplify by doing a to the power of x times b, multiplication. So remember in this one, we add the exponents. Here, if it's a power to a power, we multiply the exponents to get the new answer. Okay, so let's work with this one backwards. Okay, note that if you have b to the power of 10 times a. Note that this can be written as, because they're in multiplication, you can separate them as different powers. It can be written as b to the power of 10 to the power of a. Please, my a's are not 2's. Don't judge my a's. They are a's. Don't confuse them with 2's. Okay, you can write it as b to the power, b to the power of 10. Oh no, I thought the grade 11 is wrong. Okay, so b to the power of 10 to the power of a, or alternatively, it could also be written as b to the power of a to the power of 10. Okay, it's multiplication, so they can be either or, it's not going to change the value. Okay, yes, that is to note. Thereafter, yeah, okay, whatever, you have b to the power of x, y. This can be written as b to the power of x to the power of y. Okay, alternatively, b to the power of y to the power of x, just the second example. Okay, cool, moving on. I hope that makes sense, right? It's gonna, when we do more difficult questions, it's gonna make more sense in the questions, right? Let's talk about a to the 0 is equal to 1. Okay, basically a to the 0, a is a variable, but anything to the power of 0 is equal to 1. If I had 7 to the power of 0, this is 1. If I had 1 any amount, this is like way too many zeros, but any amount basically, let's leave it at 1 billion. I think that's 1 billion to the power of 0 is equal to 1. Okay, you don't need to know why. Please don't get into why. But you just need to know that anything to the power of 0 is equal to 1. Let's look at number 5. So with number 5, right, we have a to the negative exponent. Whenever we have a negative exponent, we can always take it, okay? If the negative exponent is in the numerator, so this term was initially in the numerator because it's a to the negative x over 1, okay? Then if it's in the numerator, I can take it to the denominator and make it a positive exponent, okay? So let's do an example. If I have b to the negative 3 over c squared. So just say I wanted to write this with only positive exponents. So in the numerator, I have a negative exponent, okay? So I'm going to take this guy to the bottom. And at the bottom, I'm going to have c squared times b. Because I'm taking it to the denominator, I can make it positive 3. And on top, I'm just left with 1, okay? If we have to do a more complicated example, if I have, let's add more to it. So if I have b to the negative 3 times a squared divided by c times d to the negative 4. So if I want to write this with only positive exponents, I just have to take them to the numerator or denominator, depending on whether they're negative or positive. So the positive ones, I want to leave where they are, okay? So there's two ways of writing this. Just say the first thing is I wanted all positive exponents. Okay, all positive exponents. Now, the b I can take to the top. Okay, so let's just annotate this guy. I'm going to take to the top, sorry, to the bottom. The d to the minus 4, I'm going to take to the top. Does that make sense? The negative ones I swap. So the negative one on top, I take to the bottom. The negative one at the bottom, I take to the top. So I'm going to be left with a squared. Let's do this. A squared times, I took the d to the top, so d to the 4, okay, over okay, c stays where it is because it's positive already, and b to the negative 3. So if I wanted to write it as all positive exponents, I could do that. Alternatively, if I wanted all in numerator, if I didn't want a fraction, if I want all in the numerator, I can simply take all in the numerator. So I'm going to have a squared. Okay, now let's write it in alphabetical order one more time. So a squared, now b to the negative 3. Sorry, this is supposed to be b to the positive 3. Yeah, thank you. Okay, so if I want to take them all in the numerator, I'll have a squared. Okay, I'm going to write it in alphabetical order because it's going to make me cry. I'll rewrite in alphabetical order, but basically a squared times d4, which are already on the top. Now I want to take c to the top. C is currently c to the positive 1. So if I want to take it to the top, it's going to become c to the negative 1. B is positive in the bottom, so it's going to become b to the negative 3 on top. So now I don't have a denominator anymore. I've written all in the numerator. So I have a squared, b to the negative 3, c to the negative 1, and d4. Okay, so two ways. If you want all in the numerator, if you want all positive exponents, then that's how you solve respectively. Okay, hope that makes sense. Okay, let's talk about number 6. Number 6 is when you have a product whole to the exponent. So you have an entire product. What is a product? A product is multiplication. So in this case, I have a times b to the both to the power of x. Okay, and how do I do it? I basically distribute the exponent to each multiplication. Please note, this is not plus. It's not plus, it is multiply. This only applies when you multiply. Okay, so obviously, if you want to work backwards, right? If I have something like 7 squared times 10 squared times 3 squared. No, let's make the number a bit smaller. 4 squared times 2 squared times 5 squared. Okay, I could write this as 4 times 2 times 5 squared. 8 times 5, 40 squared. 30 times 40, Yeah, don't quote me on that. Basically, that's how you can do that. Okay, that makes sense. Let's move on to the next one. So this is a quotient to the power. So a fraction basically to the power. And again, you distribute the power to each the numerator and the denominator. So if you have, okay, yeah, whatever, I'm not going to do an example, but I think that's only self-explanatory, right? So you can just distribute it, and working backwards, of course, let's just maybe do that example. If you had q to the power of 5 divided by b to the power of 5, this could all be written as q over b to the power of 5. Okay, please do note that. Okay, fractional exponent. Let's grab this guy and let's discuss him now. Okay, so just give me 1 second. Be back in like 15 seconds. Okay, let's continue. We're going to discuss a fractional exponent. Okay, so with a fractional exponent, it's exactly in the name. It's a fraction in the exponent. Okay, so basically, if you have, good. Hello. Okay, if you have a surd, if you have an exponent inside of a surd, okay, like this, let's just say we have b to the power of 3. Okay, remember, any surd that doesn't have a number here, we automatically assume it's a 2. This can be written as, let's do this. You keep the base the same, okay, b, and the exponent of the variable inside of the surd becomes a numerator of the exponent outside of the surd, and the denominator comes from the, which surd are you taking? Yeah, I'm taking the square root, okay. I'm taking the second root, so that becomes the denominator. Okay, so please note fractional exponent, important to know as well. Okay, or going backwards, let's maybe do an example with different values. So let's just say 8 to the power of 7. Okay, let's just make it simplifiable. If you want to take the cube root, if you want to take the cube root of 8 to the power of 6, this can simplify to 8 to the power of exponent inside as the numerator. What root are you taking? I'm taking the third root. Okay, so that becomes a denominator. And yes, this can simplify. This is division inside of the power. This can simplify to 8 to the power of 2, which is a squared. So the third root or the cube root of 8 to the power of 6 is actually a squared simplified. Okay, so yes, before we move on to surds, let's do some questions. Okay, so this is from grade 10, November 2022 paper. Let's have a look at this question. Okay, so this question says simplify. They wanted us to simplify the following. Okay, this is actually like factorization stuff. Questions are obviously like not 100%, but let's try and simplify it, right? Okay, so first things first, okay. Remember, this has nothing to do with the laws of exponents, okay, because it's not multiplication. If this was x times y squared, this would simplify to x squared y squared, okay, but this is not. This is a subtraction or a binomial. Okay, it is actually to do with the exponent rules, but we'll get there. This is a binomial squared, okay. So actually, if we have to go back to our binomial notes, squaring a binomial. Oh, yes, squaring a binomial. We need to memorize this. I would definitely recommend you memorize this and not just distribute each time. It makes life a lot easier. Okay, squaring a binomial, a plus b inside of a bracket squared. Okay, let's just write out the a minus b one as well. A minus b squared is equal to a squared minus 2ab. So just that minus changes plus b squared. Okay. So just the minus changes basically, okay? So yes, let's follow this method, right? To do our question here. So we have a minus b. So this guy is a, this guy is b. Let's square it. So remember, it's a squared. So it's x to the half squared. So it's a minus b. So it follows, it's going to become a squared minus 2 times a times b plus b squared. So now I'm going to do the minus 2 times a times b, okay, plus b squared. Okay, so in that case, here I have rule number 3, a power to a power rule. So when it's a power to a power, what do? I multiply. So I have x to the half times 2. Let's multiply this out. So in this case, I have a variable with a power, which is cool. Then I have a constant, so I can multiply my constants, which become 2 times 3 times x to the half plus 9. If I simplify this further, a half times 2, the 2's cancel, it's actually just 1. So it's x to the power of 1, or just x, minus 6x to the half plus 9. Okay. Yeah, this next one we'll just do. Okay, so yes, that's its most simplified version. So if you want to write it in order of powers, you'd say negative 6x to the half plus x minus 9. Something is wrong. What is the issue? Positive 9, thank you. The 2 is from the shortcut. So in the shortcut, you have to say times, minus 2 times a times b. Okay, it's correct for now. Let's just leave it at that. Okay, so that makes sense. Let's do this next example. We're not going to get through all, so let's just pick and choose. Half squared is 1/4. Okay, I have a problem. I'm confused. So this here, which by the way is equal to this. Okay. This you do power to a power, and you get a half times 2, which is 1. But here, you add them because same bases you add. 1/2 plus 1/2 is 2/4. No. 2, no, it's 1. It's also 1. But you don't multiply it. Guys, that's the thing. You guys are saying a half times a half. You don't multiply. If you are multiplying two things, I think the memo is wrong. If you're multiplying two bases, I get that a half times a half is a quarter, right? However, you don't multiply the bases. So in this case, here you are multiplying the bases, but you're saying a half times 2. So half times 2, that's 1. And if you separate it like this, okay, you'd have to add the exponents. So in this case, you have same base, whoops, you have same base, different exponents. It doesn't really matter what exponents you have, but in that case, you'd have to add them because that's the rule. Okay, same bases multiplied by another base, you'd add the exponents. Okay, and then you get x to the 1. Okay, that's what I have for now, but I will double check it and confirm with you guys. Okay, let's see which ones we can do. Before we can move on to surds and eventually equations and inequalities, we don't want to waste too much time. Okay, let's opt to do 1.2.3 and 2.1.2, right? The most complicated ones. Okay, look. So, by the way, also, we have been looking at doing an extra class for you. Okay, not for you guys, never mind. It's just for grade 10. Sorry, pretend I didn't say that. Okay, let's have a look at this example. Right? So here we have a really complicated exponent. Okay, I have 5 to the x plus 1 times 4 to the x to the 3 divided by 2 to the 5x minus 2 times x to the x minus 1. Okay, 10 to the x minus 1. Very, very complicated. Okay, so yes, I understand your plea, right, of spreading it out, and it can be written as distributive law. So you see, the thing is, distributive law is simpler for some people, but the shortcut is simpler for other people. Okay, so yes, for those of you who want to distribute it, remember we went through it here. Squaring a binomial, right? Remember I told you, you can distribute it if you'd like. Okay, or you can follow the shortcut. If you're going to distribute it, that's fine. Then you just do what is called first out in the last FOIL. Okay, so these questions, right? They look complicated, but you can break them down. Let's work with our 5x plus 1. We know if, as long as you know all your exponent rules, you are fine. Yeah, you guys are in grade 10, I know, sorry. Okay, so as long as you know all your exponent rules, you are fine. So whenever you see an addition inside of an exponent, you want to break it down. Okay, you always want to break it down with its basis. So how can I break this down? Remember, the backwards of law number 1 is when you have an addition in an exponent, you can break it down to each base, where it's 5 to the power of x times 5 to the power of positive 1, which I'm just going to write as 1. Then it's multiplied by. Now let's have a look at this, right? I have 4 to the power of x to the power of 3. 4 to the power of x to the power of 3. 4 to the power of x to the power of 3. So remember, this is a power to a power. So I multiply the powers. So it becomes 4 to the power of 3x. Okay. Then I have 2 to the power of 5x minus 2. So I'm not going to write this in division just because it's a minus. I'm just going to write this 2 to the power of 5x times 2 to the power of negative 2. Okay, are we making sense so far? I'm taking it step by step. There's a multiplication between, so I put my multiplication as well. Okay, so next I have 10 to the x minus 1. So I'm going to say 10 to the x times 10 to the negative 1. Okay, so I've broken all of them down. I've simplified all of them using my exponential rules. Now, what I can do and what I want to do is I want to group my numbers and my variables, my numbers and my exponents separately. So I'm going to write it like this, 5 to the 1 times 5 to the x. Now, what we need to do with 4 to the power of 4 to the 3, 4 to the power of 3x. Now, whenever you deal with questions like this, you always want to simplify things to the same base. Example, on top, I have 5 and I have 4. At the bottom, I have 2 and I have 10. Okay, so I can relate the 5 to the 2. I'm going to show you how you can get this to a base of 2. Am I going to show you? Yes, I'm going to show you. I'm going to show you how you can get this, not to a base of 2, this to a base of 5. And then you want your 4 to become, to get to a base of 2, so that it's much easier to simplify. You want the same bases, at least 2. So for example, I can't convert this 5 to 2. There's no way of relating 5 and 2. Okay, because they're not like factors of each other or anything. They're not like perfect squares of each other or anything. 2 squared is 4, not 10. Okay, I hope that makes sense. But basically, you want to have the same bases. Not everything the same base, but if you have like 2 common bases or 3 common bases, as long as you have common bases at the top, common bases at the bottom, basically you want to simplify each base as much as possible. That's the key thing. You want to simplify each base as much as possible. So the next one is a 2. 4. I can actually write 4, okay, as what? I can write 4 as 2 to the power of 2. Now, I haven't changed the value, okay? Remember that 4 to the power of 3x is equal to 2 to the power of 2 to the power of 3x, okay? I haven't changed the value. 2 to the power of 2 is still 4. I'm taking that and I'm putting it to the power of 3x. These are definitely equal, okay? Now, what I will notice here is that I have a power to a power. Okay, I have a power to a power. I hope that you guys can see that. So what happens when I have a power to a power? I multiply the powers. 2 to the power of 2 times 3x, which then becomes 2 to the power of 6x. Okay, so I'm directly going to write this as 2 to the power of 6x. Okay, now I have 2 to the power of 5x. Okay, remember we said we're doing another thing also. I want to group all my numbers. Okay, it's fine. We don't have to do that immediately. So let's do that in the next step. We can swap these back around. Okay, let's not do too much at once. Okay, so now 2 to the power of 5x is fine. Times 2 to the negative 2, that's fine. Times. Now, someone tell me, I'm not sure if you guys are going to be able to tell me, but you can try. How can I write 10 to the power of x with a base of 5? 10, just 10 in general. How can I write 10 with a base of 5? 10 to the power of x with a base of 5 somehow. So it's obviously not 5 squared because 5 squared is 25. Exactly, 2 times 5, right? But how are we going to express that? Remember, we cannot change the value. So I'm not going to, I can't say like 5 times 2 to the x. This is incorrect. I can't just like do that. I can't just say like 5 times 2 to the x. 5, okay, that's good. That's correct. Or I can't say 2 times 5 to the x, right? If you take it step by step, I still keep the entire power of 10 to 5. Instead of writing 10, however, I write 5 times 2. I haven't changed the value. That's still 10. And now I have that to the power of x. What do I have? I have 5 times 2 to the power of x. Instead of having 10 to the power of x, I have 5 times 2 to the power of x. 5 times 2 to the power of x, this is an exponent rule. It's a product that has a power, and you basically distribute the power to each product, each multiplication, whatever they call that, I forget. So this then becomes 5 to the x times 2 to the x. I have the 2 and I have the 5. That's perfect. Okay, so this then becomes 5 to the x times 2 to the x. Okay, and now I can do the same thing for this 10 to the minus 1. I can say 5 times 2 to the power of x. Sorry, this is to the power of 1. This becomes 5 to the negative 1 times 2 to the negative 1. think what you're saying is correct. It's not easy to type maths when you don't have fractions and exponents that you can use. Okay, so 5 to the negative 1 and 2 to the negative 1. Okay, so now I have a bunch of numbers and variables, right? So the easiest way I can actually go about solving this is now grouping my numbers and grouping my variables. So on top, I'm going to put my numbers first. So 5 to the 1, which is just 5 times. Okay, so actually, before I do times, I'm going to, at the bottom, I'm going to write my numbers as well. Let's use different colors. Let's change it up. Let's use dark blue and purple. So on the top, I'm going to group my numbers. So I have 5 as one of my numbers. At the bottom, I have 2 to the negative 2, I believe. Let's write that clearly. 2 to the negative 2 times I have 5 to the negative 1. It's not right in different colors. We need to write in the same color. Okay. 2 to the negative 2 times 5 to the negative 1 times 5 to the negative 2. Okay. And all of this, it's still multiplication. So still like multiplied by. Okay, now I'm going to work with my variable terms separately. So 5 to the x times 2 to the 6x. Okay, and then at the bottom I have, let's write the 5s first, I guess. So, okay, it's fine. It doesn't really matter. 2 to the 5x times 5 to the x times 2 to the x. That's about it. Okay, so I haven't changed anything. Absolutely nothing. I'm just arranging it differently, maybe for you to better understand how you can simplify this. Right now, what I can actually do is I can put this in my calculator and it will give me a simplified version of the numbers. Okay, if you'd really like, you can do it separately. But I mean, at a grade 10 level, I think the main thing they're testing in this question is your laws of exponents knowledge, not if you know what the value of 2 to the negative 2 is. So you can actually put this entire thing on the calculator. Okay, to get a value, I'm going to do that right now. So just the numbers, to simplify the numbers. So 5 over 2 to the negative 2 times 5 to the negative 1 times 2 to the negative 1. So that gives me 200. So if I don't get a fraction, that means it's on top. It's like 200 over 1. That gives me 200. Okay, so 200 over 1. And now what I'm going to do is I'm actually going to separate. You don't have to do this, but I'm going to separate it with 5s. So 5 to the x divided by 5 to the x. And then I'm going to separate the 2's as well. So I'm going to have 2 to the 6x over 2 to the 5x times 2 to the x. Again, I haven't changed the value of anything here. Because when you multiply in a straight line, so numerator by numerator, denominator by denominator, and you end up with what we have back there, right? Maybe we won't do this, maybe you won't follow this, but I'm doing it for the purpose of understanding. Okay, so now I can simplify. So with the numbers, I'm left with just 200, which is fine. It's 200, right? Times 5 to the power of x. So when I have two bases which are the same in, so, okay, you can say 5 to the x and 5 to the x is the same thing. When I divide them, I get 1. That's fine. If I'm talking exponents, if I have the same basis in division, I say top exponent minus bottom exponent. So 5 to the power of x minus x, basically. Which x to the x is actually 0. And then anything to the power of 0 is 1. But let's just do it in terms of exponents. Now, what I can do at the bottom here, let us simplify this before we carry on. 2 to the 5x and 2 to the 2x. 2 to the 5x times 2 to the 2x. Remember, this is bases, same bases with different exponents. In multiplication, I add my exponent. So this becomes 2 to the power of 7x. So I'm going to, instead of that, I'm going to write 2 to the power of 7x. Okay, and thereafter, I can say same basis in division. I can subtract the 2, top minus bottom. I get 5 to the power of 6x minus 7x. So I get 200 times, this becomes 5 to the power of 0, which is 1, times 5 to the power of negative x. Something is wrong. x's are supposed to cancel. It's not 2x, it's just x, so it's supposed to be 6x. Sorry, this is supposed to be x. So this is equal to 6x, and this is equal to 6x, and this is equal to 6x minus 6x, which is basically 5 to the power of 0, which is 1. What am I doing? Where did I get that from? Okay, correct it now. Okay, and then my answer, my final answer is 200. Okay, alternatively, right, if that maybe the too many ways is a bit confusing, let's take it from this step once more. And let's solve it slightly differently, right? Not the same way, but slightly different. So remember, I have same bases, 5, 5, 5, 5. I have different exponents. Sorry, I have 2, 2, 2, 2. Okay, so what I can do is I can write them all under one exponent, and I'll show you how. So this is going to be 5, all under one, so all over one base, sorry. So on top, remember, these are multiplication, so I add the ones on top. But the ones at the bottom are division, so I subtract them. So this becomes 5 to the x plus 1. So these are from the top. Minus, what's at the bottom? X. Minus x. What's at the bottom? Minus 1. So minus 1. And I can multiply that by the base of 2 because that's what I have. On top, I have 6x. So all the ones on top I add. So I just have 6x. All the ones at the bottom I minus. So minus 5x minus 2 minus x minus 1. Okay, when I simplify this, I get 5 to the x plus 1 minus x plus 1. X and negative, okay, we'll get there, times 2 to the 6x minus 5x plus 2 minus x plus 1. When I simplify it again, x and negative x cancels. I'm left with 5 to the power of 2 times these all cancel because it becomes 6x minus 5x is 1, minus 1 is that, times 2 to the power of 3. This is equal to 25 times 8. This is equal to 200. Okay, so that's another way. It's not 2 to the 1, it's 2 to the 3, so just be careful there. Okay, let's move on. Let's do this last one quickly, right, before we leave. Yeah, so unfortunately, we will have to leave, and then next week we'll do, we'll continue with equations and surds as well. So, there's probably 2 ways of solving this. Should we do it now? No, let's not do it now. Should we? Okay, let's do it. So I have 3 to the x minus 2 times 3 to the x minus 1 is equal to 3. So naturally, whenever you see this, you want to separate it into its bases. 3 to the x is equal to, not equal to, minus 2 times 3 to the x times 3 to the negative 1. Now I can actually simplify that number. It becomes 3 to the x. I can say negative 2 times 3 to the negative 1. It becomes 2 over 3. Should I do that? No, not for now. It's fine. I can leave it as 3 to the negative 1. So there's actually 2 ways of solving this. The first way is by identifying that in 3x and 3x is common in both terms. So I can actually take it as a common factor. I can take 3x as a common factor, and I'm left with negative 2. Sorry, no. When I take 3x as a common factor here, I'm left with 1 minus, and I divide this by my common factor. That cancels. I'm left with 2 times 3 to the negative 1 is equal to 3. So now this is 3 to the x times 1 minus 2 times 3 to the negative 1. So I'm going to take it over as division. So 3 to the x is equal to 3 divided by 1 minus 2 times 3 to the negative 1. This is actually 1 minus 2 over 3, which is 3 over 2, and then blah, blah, blah. So let's simplify this. We can just take it step by step. This is equal to 3 over. That becomes 2 over 3. 1 minus 2 over 3 is actually 1 over 3. Okay, and then when you simplify that, you actually get 3 to the x is equal to 9. Okay, now remember, when you have an unknown exponent, you want your bases to be the same. So how can we write 9 with a base of 3? This one is easy. You can use your calculator, input 9, say equals to, and use shift fact. Have we learned that before? You can say shift fact, and it basically gives you 3 to the square. So 3 to the x is equal to 3 to the 2. And when the bases are the same, they can cancel, and you get an answer of x is equal to 2. Okay, I hope that makes sense. Okay, so let's end there, right? Next week we'll be doing surds, hopefully, and then equations and inequalities and trig. Let's see, we might finish, we might not, unfortunately, just because we started late and I don't want to rush through anything, because I feel like you rather understand the topics that we are doing instead of rushing through it and trying to finish everything. Otherwise, then you might as well just go learn in school. It would be the same thing. Okay, but yeah, if there are no questions, we can end it. I just want to note that firstly, the document, a reminder that the document that I'm doing will be uploaded to the Google Drive. The link for the Google Drive will be found in the group description. Something that has been added to the drive is a breakdown of the topics that we'll be covering per term. Okay, so many of you have been requesting it. So yes, unfortunately, I can't give you a timetable to say which days we are going to do what, but at least I can give you the order in which we are going to be doing the topic, so you know that when we finish this topic, you know what we'll be doing next time. So yeah, it can be found in the drive, so please go have a look at that, and you guys can use that. But yeah, otherwise I will see you guys next week, where we will continue doing surds, and then yeah, equations, inequalities, and then trig as the next topic. Are there any questions? Doesn't seem like it. Okay, cool, perfect, no problem. I shall see you guys then next week. Thank you guys so much for joining. Jazakallah khair.